Hi everyone, welcome to the fourth and final video going through some past exam questions on the topic of strong bases and KW. The first question here is actually mostly about Ka actually, and I think this is a question that we've seen before in one of the previous videos on acids. So I'm going to run through this one hopefully fairly quickly. What's the difference between a strong acid and a weak acid? So a strong acid fully dissociates. A weak acid partly dissociates. What is the expression for Ka? So Ka is going to be, if it's in this nitrous acid, so it's going to be H plus NO2 minus, and then the concentration of the acid itself on the bottom. It wants us to then calculate the pH of this weak acid. Okay, so what we're going to do is we're going to do the H plus squared trick that we usually do. Okay, and then we're going to rearrange that. I'm not going to go through that rearrangement because you can see it in some of the previous videos. But we're going to end up with the H plus concentration being the square root of Ka times HNO2. So therefore the H plus concentration is the square root of the Ka value from up here, okay, 4.43 times 10 to the minus 4 times the concentration from here. As I said, if you are not comfortable where did this come from, I suggest you go and have a look at some of the videos on weak acids and Ka. So we're going to do square root of 4.43 times 10 to the minus 4 times 0.375. So our H plus concentration is 0.013 essentially. So therefore the pH is the negative log of that value. We're going to get 1.89. Right, here we've got this acid-base pairs question. So here they want you to recognise that nitric acid is the strong acid, whereas this one is a weak acid. So this is going to be the acid, this is going to be the base, and the HNO3 is going to donate a proton to your acid there, and we're going to make NO3 minus. And therefore, if that's the acid, this is its conjugate base. So we'll call this base 1 and acid 1, and this can be base 2 and acid 2. Okay. If we then see they're going to link in some bits about KW and bases now. So we're now looking at calcium hydroxide. They're saying it's a strong Bronsted-Lowry base. What do we mean by a Bronsted-Lowry base? Well, if a Bronsted-Lowry acid is a proton donor, a Bronsted-Lowry base is a proton acceptor. It then wants us to calculate the pH of calcium hydroxide. Okay, so calcium hydroxide is a base, so therefore we're going to be using KW. So we're going to write that out first of all. Okay, you always want to start by writing out KW or Ka if it's an acid. We want to calculate the pH, so therefore we're going to want the H plus concentration. So this needs rearranging. It's going to be KW divided by the OH minus concentration. Okay. Now, it doesn't mention the temperature anywhere here, so we're going to have to assume that it's just the normal value of KW, unless they've told us otherwise. Okay, they will always tell you if you're not supposed to use that value. So the H plus concentration is going to be 1 times 10 to the minus 14 divided by the OH minus concentration. And here's the only bit where we need to be careful. If the concentration of calcium hydroxide is 0.04, well, when that dissociates, that's going to end up making a calcium ion and 2 OH minus ions. So the concentration of the OH minus ions is going to be double the concentration of the molecule itself. Okay, so we're going to use a concentration of 0.08 for the OH minus ions. Okay, this is kind of the only trick they can do, really, is go, haha, it's got 2 OH minus ions in it. So just watch out for that. So then we're doing 10 to the power of minus 14 divided by 0.08. 1.25 times 10 to the minus 13. So therefore the pH is the negative log of 1.25 times 10 to the minus 13. 12.90. That's a sensible pH for a strong base, isn't it? Okay, calcium hydroxide is then added to the nitrous acid, so we're linking the two things together. Write the equation and the ionic equation. Okay, so calcium hydroxide is added to nitrous acid. It's going to make the calcium salt, so we're going to need two molecules of the acid here. So we're going to end up with calcium NO2, because that's the negative ion, and then we're going to get two water molecules with the OH minus and the H plus. So then the ionic equation, well, what's going to happen here is the calcium is going to cancel out and the NO2 ions are going to cancel out. Okay, and we're going to be left with just our ionic equation for neutralization because we've got an acid and an alkali. So we're going to end up with two OH minus ions from the calcium hydroxide, two H plus ions from the acid, making two water molecules. And you could cancel out all the twos if you wanted to. Finally, this is just a totally separate question. Just calculate the pH of a solution of a base. Okay, this is one that hopefully we're familiar with now, having done this sort of thing 3 or 4 times. It's a base, so we're going to start with Kw. They want the pH, so we want the H plus concentration. It hasn't mentioned anything about the temperature being strange, so we're just going to use the normal value of Kw. And if the concentration of sodium hydroxide is 0.4, then the concentration of OH minus is 0.4. Okay, we've got no tricks like calcium hydroxide's got 2 in it or anything like that. This one's straightforward. So we're going to calculate that. 10 to the minus 14 divided by 0.4. 2.5 times 10 to the minus 14. So then the pH is the negative log of 2.5 times 10 to the minus 14. .60. And again, a sensible value for the pH of a strong base.